Let's say that I have 16 friends and they're playing darts at a local pub, right? This is a good thing to do. I was raised in England, so darts and pub, that sounds like a good thing to do, okay? Now, every friend wants to play every other friends. So how many matches must be played to make that happen, okay? Well, the way that we're going to do this is we're going to say, all right, so each match looks like this. I choose player 1 and player 2, right? So how many ways can I choose player 1? Well, there's 16 players, so 16 ways. Player 2? Well, there's only 15 because, I can't pick the same player twice, Okay, so that's the answer, right? But notice that I could have picked Bob and Mary and Bob, right? So I have to worry about reorderings. So I need to divide that by the number of ways to reorder two things. And I'm going to do it slowly, right? So how many ways, if I have two things in my hands, how many ways can I place them down? Well, the first one, I could choose either of the two things. The second one, only once left, right? So the total number is going to be 8 times 15, and what is that, 120? Okay. I could be wrong on the arithmetic, but the plan for how to get there is what's right. Okay. All right. So yeah, that's how many matches we have to play. That's an awful lot of matches. That's an awful lot of beer too. I don't recommend that, especially not if you're underage. Okay. So let's see. Now, how many ways can I find the best player in a single elimination tournament? Okay. How many matches must I play? Well, let's see. There's 16, right? So I'm going to arrange this. This is like March Madness, right? So I have a bracket: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And I have matches like this. And then, of course, like that. And like this. And then the big match, right? So I have 1 here, 2, 4, 8. I add all this up and I get 15. Okay, right? 1, 2, 4, 8. We get excited, right? Those are the powers of 2. So I'm adding the powers of 2, and I have 2 to the 0 plus 2 to the 1 plus 2 to the 2 plus 2 to the 3. And that is equal to, this is a geometric series, isn't it? So we actually know the answer to this. This is 2 to the 4 minus 1 divided by 2 minus 1, which is just 1, so we leave it like that. Okay, that's 16 minus 1, 15. Great! We got geometric series in play to help us do some of the counting. Okay. By the way, this worked out really nicely because I started with a power of 2. What an accident, right? Of course not, I planned it that way. But anyway, suppose I hadn't planned it that way. Suppose I told you that there are 25 friends and we want to have a number of matches so that single elimination we find the best player. How many matches do we need? Oh no, you can start building a tree somewhere between 16 and 32. Don't bother. Think of it this way. Each match eliminates one player, right? It's single elimination. And I have 25 friends, which means that I need to eliminate 24 of the friends to find my winner. I need 24 matches to eliminate those 24 friends. That's another way you can get this. I got 16 players. I need 16 minus 1 or 15 matches so I can eliminate all but the best player under these rules. Okay, so we actually found 2 ways of counting that. Pretty cool. Okay, now let's try this example. Okay, now one of the things about being in a pub is you start thinking, I want to play in teams. So let's make teams, right? So we'll put some solid and striped balls in a bag because, we're at a pub. We can actually find those. And each player draws one of the balls at random. And so we now have the solid versus the striped players. Okay, now I want to guarantee that each team has at least 2 players. So how many of the balls must I draw to make that happen? Well, this is a pigeonhole principle, right? So I have 2 pigeonholes, right? Those are the teams. And I want to guarantee that one of the pigeonholes has at least 2 pigeons, right? Well, that's n plus 1. I need at least 3 draws, right? So at least 3 players need to draw before I can guarantee that at least one of the teams has 2 people in it. Excellent. Now, what about, I want at least one of the teams to have 8 players, right? I want a big team. And what I'm thinking is I got 16 people, right? So, I want at least one of the teams to be half the friends. So how many times must I go to that? Well, the answer is 15. Okay, because here's what could happen. As I'm allocating the teams, right? The first team, team A gets one person, team B gets one person. Then team 2 gets one person, team 1 gets the second person, team 2 gets the second person. And I keep doing that. And now both teams have 7 players in them, right? That means I picked 14 players in total. In order to get the team with 8 players, I need to draw 1 more, and now they have no choice. This is actually a generalized version of the pigeonhole principles. Now what I'm saying is, let's see, how many pigeons must I have so that each pigeonhole has at least these many people? And the answer is, this many pigeons. The answer is the number of pigeons that I want times the number of pigeonholes plus 1.